Okay, today we're going to look at two different methods of factoring. One is called difference of squares, and one is factoring by grouping. And you can see that we're going to start with difference of squares. So difference of squares is exactly what it sounds like. It's difference, so you're subtracting, and you're subtracting two squares. We're just going to say a squared minus b squared. And it's a really easy pattern. If you spot it, it's super easy to do because there's really no work. It just factors into a plus b times a minus b. Now, before we get into actually factoring by difference of squares, I just want to look at why this works. So if we check by multiplying a plus b times a minus b, and you can do this by FOIL, you can do it by setting up boxes. I'm going to look at it as distributing. So if I distribute the a, first of all, to both terms in the second factor, a times a is a squared, and a times negative b is negative ab. And then we'll multiply the b, we'll distribute that to both terms. So b times a is positive ab, and b times negative b is negative b squared. And if we take a look at this, we can see that we have these two terms in the middle that are like terms and they're opposites. So negative ab plus ab is a zero pair, and so they're going to cancel out to equal 0. And then that just leaves us with a squared minus b squared, which is the difference of squares. And the reason I bring this up is because it's really important that we have the opposite signs that can cancel out these terms in the middle. So that's why it's always going to have to be subtraction in between. That's why we have to call it difference of squares. It's not sum of squares, it's difference of squares. And this minus sign, this negative b squared, means one is negative and one is positive. And then those opposite signs give us this zero pair in the middle that always will cancel out. So that's what you're looking for with difference of squares. But this is just the why behind it. How it actually works is super easy. If you see subtraction between two perfect squares, you take the square root of both, and one gets a plus and one gets a minus. So let's take a look at some actual examples. So here's a couple. We can see that there's subtraction in between the two squares. X is obviously squared because it says it, and we know that 25 is 5 squared. So the square root of x squared is x. The square root of 25 is 5. One gets a plus, one gets a minus, and you're done. And it's literally that easy. Over here, again, I can see that it's subtraction, and I have two perfect squares. Again, the x is squared, so that's obviously squared. 4 is 2 squared, and 9 is 3. So we'll take the square root of 4x squared, and we get 2x. We take the square root of 9, and we get 3. And one gets a plus, one gets a minus. So there's difference of squares. So I have some for you to try. So go ahead and give these a try. Pause the video. Give these a try. And then when you're ready, you can unpause the video and I'll show you the solutions. All right, here are the solutions to them. I did throw a couple little tricks in here. So first of all, this one, subtraction between perfect squares. Square root of 25x squared is 5x. Square root of 16 is 4. And one gets a plus, one gets a minus. And that's all there is to it. If we look at the second example, the thing that I didn't bring up, but remember the golden rule of factoring, we should always be looking for a greatest common factor first. So although these were perfect squares, before we actually use difference of squares, we want to factor out the common factor of 4. So if I factor out a 4, I'm left with this, and then these are still perfect squares, so it still is the difference of squares. Notice the 4 just comes down for the ride, that common factor. We don't want to forget about it. It's really important that you bring it down. Square root of 4x squared is 2x. Square root of 25 is 5. One gets a plus, one gets a minus. Now, if we look at this third example, it's the difference. And yeah, x is squared, but 18 and 8 are not perfect squares. But there is a common factor of 2. And if you factor out the common factor of 2, look at that, it reveals that we actually do have some perfect squares, and so it is still difference of squares. Square root of 9x squared is 3x. Square root of 4 is 2. One gets a plus, one gets a minus. Again, don't forget that common factor of 2. And the last one I made was a trick. Yes, these are squares, but it is not difference of squares because that is a plus sign. So if that's a plus sign, it will not factor. It is prime, it is not factorable. So that's difference of squares in a nutshell. Let's take a look at factoring by grouping now. So factoring by grouping is best shown with just an example. So I have an example right here. One thing is you can see that we're using factoring by grouping with 4 terms. And so what you do with factoring by grouping is you actually look at it 2 terms at a time. And if we look at the first 2 terms, we want to look for a common factor just in those. And there is a common factor of 2 in the coefficients, and both terms also have at least an x squared, so there is a common factor of 2x squared. And that would leave us with 3x plus 4 when we factor that out. So you just look for greatest common factor 2 terms at a time. And you can double check by distributing back in. 2x squared times 3x would be 6x cubed. 2x squared times 4 is 8x squared, so this is good. Okay, we're going to look at the next pair of terms. And again, we're looking for a greatest common factor. And this time we can see there's a 3. It's a positive 3, so I'm going to put plus 3. And when I factor that out, it leaves me with 3x plus 4. Again, I can distribute back to check. 3 times 3x is 9x. 3 times 4 is 12, so that's good. Notice that these match. There is a 3x plus 4 in both of these. And that is now a common factor that we can factor out. So I factor it out, and then I look at what's left, and that gives me my other factor, 2x squared plus 3. And that is factoring by grouping. So again, 2 terms at a time, look for a common factor, see what you're left with. Next pair of terms, look for a common factor, see what you're left with. These must match. If they don't match, factoring by grouping is not working. So if they don't match, for us this year, we're just going to say it can't be factored. You will learn other techniques in other classes, but they have to match in order to do this factoring by grouping. Okay, let's take a look at another one. So let's look at this one. So what do you notice about this one first? And hopefully you're thinking, oh, hey, there is a greatest common factor, because yes, there is. If we look at each one, each coefficient is divisible by 2, and there is at least 1 x in each term. So I'm going to factor that out first. I'm going to factor out a 2x, my greatest common factor. And then we look at what's left, and we have a 10x cubed minus 14x squared minus 5x plus 7. Okay, and now we're going to go ahead and factor by grouping what's inside the parentheses. Everything else is going to come down for the ride. Notice I do need this set of parentheses to show that the 2x is going to get multiplied by everything that I'm doing on the inside. Okay, I look at pair of terms at a time. Greatest common factor here is going to be 2x squared, and I'm left with 5x minus 7. With these two terms, don't forget when you are factoring and looking for a greatest common factor, if there's ever a negative that leads the terms, always factor out that negative also. So the greatest common factor may look like just a positive 1, but because of this leading negative, I'm going to go ahead and factor out a minus 1. And that leaves me with a positive 5x minus 7, and sure enough, these match. So I am left with, I still have this 2x here. I have that 5x minus 7 that matches, so I can factor that out. And then I am left with 2x squared minus 1. Now, there's a lot going on in this problem, so if you need to go back and rewatch my explanation, feel free. Pause the video to take a look at it before we move on, but that's how you do this problem. Okay, so here's some for you to try. Go ahead and give those two a shot. Again, pause the video, take a look, and in a moment, I will show you the worked out solutions. Okay, here we go. Let's take a look at these. So if we take a look, the first example has no greatest common factor. So we can just start factoring by grouping. Look at the first two terms. There is a greatest common factor of 4x squared. When we factor that out of these two, we're left with 3x plus 2. The second pair of terms, the only thing that goes into both 3 and 2 is a 1, and normally we wouldn't factor out a 1, but for factoring by grouping, it's going to be important that we write that plus 1. So I'm going to write that we are factoring out a positive 1, which still leaves us with 3x plus 2. But now the 3x plus 2's match, so we can factor them out. And then that leaves us with 4x squared plus 1 as our other factor. Okay, let's take a look at this last one. This time there is a greatest common factor. 2 can go into everything. So if we divide everything by 2, that leaves us with 4x cubed plus 5x squared minus 16x minus 20. And I have that 2 that I factored out in front. So now I'm going to look at everything here factoring. Again, notice I have this big set of parentheses to show that 2 is going to get multiplied by everything on the inside. So I look at two terms at a time. There is a common factor of x squared that can come out, which leaves us with 4x plus 5. This time, again, we're leading with a negative, so I'm going to factor out a negative, and there's a 4 in both of those numbers. So I can factor out a negative 4, which leaves me with a positive 4x and a positive 5. And the 4x plus 5's match, so that's good. That's one of our factors. And then we have x squared minus 4 as my other factor. But wait a minute, we're not done, because I have difference of squares. So it's the problem that keeps on giving, because we can keep going. So I still have these factors that come down, but then x squared minus 4, the square root of x squared is x, the square root of 4 is 2, and 1 gets a plus, 1 gets a minus, because it was difference of squares. So there you go. There's difference of squares and factoring by grouping in a nutshell. Have fun.